Hello everyone, welcome back to Electronics Prepper, the channel where we try to learn as much as possible about electronics to become more self-reliant with technology and prepare for the future. Today's video is going to be more of an inspirational video. I'm not gonna be showing you any new circuit, although I will in the near future. I have some videos prepared. But no, today's video is going to be more of an inspiration, and I'm going to be giving you an alternative solution for creating your own circuits. When it comes to building your own circuits, many of you, especially in the Western world, many of you seem to enjoy just placing an order to a well-known PCB manufacturer. There are quite a few out there on the market. I don't know them all. I just remember the top two ones, which is JLC PCB. A lot of people are even sponsored by them. And PCB Way, if I remember correctly, is their name. They are also pretty big PCB manufacturers. Now, a lot of you seem to be big fans of just externalizing the process of creating a circuit board, a printed circuit board, actually, to be more specific. And you do this out of, I don't know, several reasons. Probably the biggest reason is so that you don't have to bother with the actual creation of the PCB himself. But the problem is, by choosing to externalize this process, you are essentially making yourselves dependent on those companies existing out there on the market, having good prices, and being able to ship those PCBs to you, which it's not a problem right now. It's probably not going to be a problem in a few months, or maybe not in a year or two, but definitely in the medium-term future, this will be a problem. Due to where society is heading, where humanity is heading, this will definitely be a problem in the future at some point in time. I'm not gonna go too deep into this discussion because it's a bit besides the point. Who happens to understand what's happening in the world right now and where we are headed simply understands and does not need me to explain anything more. Who doesn't, well, from my life experience, I've seen that there's nothing that you can do, nothing that you can say really to these people to make them understand. So I'm going to give you in this video a couple of alternative options for building your own PCB in case you don't want, or in the future you will not be able to just place an order to PCB manufacturing and just wait for the order to be shipped to you. In case this sounds strange to you and you don't understand why, I guess this video is just not for you. So let me just simplify things for you. If this is the case, then this video is not for you. Just jump over and I'll see you in the next videos. Now, when it comes to building your own PCBs, the first thing that you need to determine is whether you actually need a PCB or you can just be content with something else. And what I'm talking about is the fact that PCBs are relatively new technology, okay? Sure, I'm using the word relatively very loosely. They've been around for quite a few decades. However, what do I mean by relatively new technology? I mean that PCBs have not existed since the beginning of electronics. In fact, at the beginning of electronics, components were literally soldered together through their wires, and it was the so-called point-to-point method of connecting components together. You can still see this method in very old devices, you know, like old radio receivers, and just in general in very old electronic devices that were using vacuum tubes. You can still see this this sort of technique that either doesn't have PCBs at all, or it has some form of boards, but they are not quite like we are used to nowadays. Okay, so PCBs were invented a bit later than that point in time, and they've become so popular due to a whole number of reasons. However, PCBs alone are not the only option that we have when we want to create a circuit, and therefore when we want to create a device, you know, because a device can have one or more circuits. So there is a particular way, and I'm going to go in a moment to the workbench, and I will show you up close. But there are two ways of using more or less point-to-point connections between components, especially if we are using brand new components that do not involve a PCB. One method involves the existence of a circuit board, or just a board that does not have circuits or the means to create circuits on it. And it is used only as a, let's say, substrate, only as a surface on which to be able to place components that should stay together. Okay, and there's another way that I've come up with, and it involves 3D printed pieces of plastic that help you. They basically form also like a hard material, a hard surface on top of which to come with components and solder them point to point. Okay, I have used this method for quite a while now. I am no longer creating actual PCBs myself. Even when we want to create an actual PCB, we still have a way of creating it ourselves by using very sharp tip permanent markers to draw the traces on the copper surface, and then immersing that board into chloric ferrite or ferric chloride or something like this. I don't know how you call it in English, so that it will corrode the extra copper that has not been covered by permanent marker, and then when it's done we can clean it in warm water, and then that's it. We drill holes, and that's our PCB. The problem with that technique is in how we manage to... So this basically involves manual work of drawing the circuits onto the copper board. There is another way which is used by some people, and that's the thermal toner transfer method, which involves printing the circuit on a special kind of paper in a laser printer, and then using something like a clothing iron or something like how do you call that, very hot presser. No, that's not the right word, but the word it escapes me right now. So anyway, using pressure and high temperature to basically make the toner from that piece of paper, detach and attach to the copper board and stay there, so as to cover, you know, the copper layer, and this way to avoid drawing the circuits manually with an actual permanent marker. However, the problem with the toner transfer method is that for people like me, it never seems to work properly, or sometimes it never works at all, you know. It seems to be very difficult to find the right amount of time and pressure and temperature to use on the iron, and the right paper that would allow toner to transfer from paper to the copper layer. Anyway, I typically avoid using that method, and therefore I avoid in general creating actual PCBs, actual printed circuit boards. I use that method only when I really have to, okay? But other than that, whenever I can, I use these two methods that I will show you today. So one of the methods was actually suggested to me by a viewer of my other channel, of my electronics channel in Romanian, and at that moment in time I kind of rejected the idea. I didn't like it. I know it sounded a bit silly and not good enough, but at some point in time I decided to just give it a head and go ahead and try it. Because I decided to just test it on a test circuit that I didn't care, and I saw that it had good results, and therefore I started using it more and more. On top of that, at some point in time, I ordered these things from an electronics store. Now, when I ordered these things, I actually thought that they are actual PCBs with one layer of copper on them, okay? The description of these boards said nothing about them not having copper at all. So for me, it was a bit of a surprise, obviously an unpleasant surprise when they arrived at home, and yeah, I opened the package and I saw that these are just a thin layer of the same sticlotextolite material from which PCBs are made, but without copper at all. Initially, I was very disappointed by my mistake in choosing the right product. However, I came to realize that it's not that big of a deal because I can actually use it. So, in order to use this, we need to basically drill holes just like on a regular PCB, except and place components, except that unlike in a regular PCB, we cannot make use of the copper to create traces. So instead we have to use something else to connect the components themselves. Now, okay, so if we use brand new components, okay, they come like this. Most of them come with pretty long wires. These wires can be easily used on the back of the board to be soldered together and therefore form circuits themselves, okay? And whenever we have components that don't have long wires, we can use another trick. If we go ahead and buy Ethernet cables, okay, that are relatively cheap, those cables are used for interconnecting computers with switches, routers, stuff like that. Those are relatively cheap. They are sold per meter, or sometimes you can buy an entire roll of, I don't know, 10 meters, 25 meters, 50 meters, because they are used heavily in networking, in computer networking. Those cables actually on the inside are formed by 4 twisted pairs of cables. So if you remove the outer isolation on those cables, you will find on the inside 4 pairs of cables like this, like I'm holding now. Okay, 4 pairs that are twisted together. So in total you have 8 wires. Okay, and if you strip the isolation from each of these wires, you will essentially get relatively thin copper wires that are very easy to work with. You can bend them very easily, you can cut them very easily, you can work with them very easily. Okay, so whenever you don't have enough length in your components, in the legs of your components, okay, focus, come on. Whenever these are not long enough, or perhaps you want to use second-hand components, I mean recovered components from various boards, and they of course are have very short legs, then you can easily use this kind of wire, okay, to solder and create circuits. So in the end you will get something like this. This board is essentially a piece of this kind of board. I will link it in the description for you to see which one it is. Okay, and I have various components on the top side, and on the back side I have their wires, or extra wires from Ethernet cables soldered together to form the actual circuits, and overall I get a pretty robust circuit. Okay, as you can see here, I also have a couple of power transistors mounted on a radiator each, because they will heat up during working. I will present to you this particular circuit in a future video, because this is an LDO power supply. I will talk about it in a separate video, because this video is not about the circuit himself, but it's about how to build such a circuit and the fact that this possibility, exists. Again, initially when I heard about this, I rejected the idea because I didn't thought it would be good enough. But after I've done it once, I saw that it is actually good enough. So why not? So the process is pretty simple. You of course start with the schematic, for which you design a PCB schematic, just like you would usually design it. This is scaled up to fill the entire page. This is just to help you, to help me when I build this, know which component is placed where. Okay, but in the end you will have to print on a regular piece of paper. You will have to print the PCB schematic, both in normal version and in mirror version. Okay, in normal version what you see here is basically the laying of the components. So basically, okay, what you see here is how it looks on the component side, and on the mirror, in the mirror version represents the side with the circuits themselves. Okay, so the first step when you're doing this is to basically take the normal layout, overlay this board on top of it, take a marker. You see that this board is semi-transparent, okay, so you can easily see the drawing underneath on the paper. Of course, you do this by placing it on your table and holding everything well in place. And then you take a marker and you mark only the holes. Okay, the holes from each component. So you put a dot with a marker You need to use a narrow point marker, okay, narrow tip marker, and you just draw the holes so that you know where to drill the holes. Okay, once you have drawn all the holes, and perhaps you will want to draw the outer boundaries of the board so that you know how to cut it, you will then go ahead and drill the actual, cut the board, drill the actual holes. Okay, and then when you have the board with your holes, you're gonna flip it and you're going to do the same thing but on the mirror version of the circuit schematic. And you're going to overlay the board, which will have holes, on top of this version, and you will of course have to align it well enough for all the holes to fill to just drop in the right place. And with the same marker you're going to come now and you're going to basically draw all of these circuits. You're going to connect all of the holes that you've drilled previously so that you will know where do you need circuits to be, so where you will need to create circuits. Okay, and once you have drawn all of these traces with the marker, and therefore you will know which holes need to connect to which other holes, you're gonna start to place components one by one, and you're going to, place a component up to the bottom, hold it, bend the wires of the component in the right direction, place two components at first, solder them together, two components that are actually making a connection, solder them together so they have one stable point, and then move to the third component, solder those wires together, and so on and so forth. So you will gradually fill the board with components and create the circuits here, and in the end you will have this, something like this. Okay, it's a very good technique. It's simple, it's easy, you don't have to bother with corroding copper in order to create actual traces. It works for, I would say, 99.9% of circuits that you want to build. So it's definitely a good choice to take into consideration when you want to have your own PCBs, but you don't want to, have an actual copper circuit, or you don't want to, place an order to a different company. There's yet another way that you can do this that does not involve you having this kind of board, which is an even cheaper method, and it's a method that's even more easily available to us, especially when we run out of these boards and we don't want to wait. We place an order, but we don't want to wait until they come. We just want to quickly make a circuit together. Well, if you have a 3D printer, okay, so this method will only work if you actually have a 3D printer, or if you know someone that can help you with this thing. So if you have a 3D printer, you can create a structure like this, which is basically a plastic grid, okay, that has many crenels. Okay, these crenels are precisely I don't have one. Yeah, I don't have an integrated circuit at hand. I should have gotten one before I started filming, but anyway, these crenels are spaced apart precisely, come on, focus, precisely so you can place integrated circuits here. The classic deep integrated circuits that have wires, okay, not SEMD components. And they will fit well because the distance between these crenels is calculated precisely. So Of course, if you choose to work with such a plastic board, you will have to, you know, design yours and build it. Or I will put on Patreon, I will put the design for this particular board, and you can just download it and print it. So if you have a 3D printer, or a friend of yours has, you can 3D print yourself several of these boards. They are very cheap because there's not much plastic in this thing, but these are very good for creating circuits. Okay, so and I'm gonna show you a different circuit that I made using this technique. But here I've used an older version of this board that has much fewer kernels. This in my right hand is a newer version compared to this. So on the surface, on all of these kernels, you place your components, okay, and you bend the wires of the components as you see fit, as you need them to be, and you simply solder them together. I have here a simple power supply with 2 transistors, 1 resistor and 2 diodes. So very simple, but you can build things that are more complex as well. So on the surface you come with your components, and let's say these are the wires of the components, right? You use these kernels to, you know, place your components, and you can solder them together. And if you need to create circuits behind those components, there are on the side below, there are these holes, 2 holes per each channel. Let's say that this is a channel, right, or a column. There are 2 holes per each column, so you can take one of these wires and put them here, okay, and you can basically create circuits underneath components. The components would come here on the top, right? And you can easily build, again, almost any kind of circuit using this technique. It does have 2 disadvantages that this other technique doesn't have. One is the fact that you will have bigger spaces between components. So basically the same circuit that you would create on an actual Stiklotextolit board would take more space on such a plastic board, because there are fewer places where you can actually place those components. So overall it will take a larger space. And the second disadvantage is that overall this is less robust than this, okay? But it's still not an option to be ignored. It's still an option that you can use, can potentially use in some cases for some projects, okay? So why not? Take this into consideration. And just like with this option, when the wires of each component herself is not enough, you can easily come with this kind of wire that you've taken from Ethernet cable wires. So these are very, very good simple solutions that you can use to build your own circuits whenever you need them. Whenever you don't want to rely on something or someone else, and also again in the future when we will no longer be able to rely on anyone else, you know, any such technique will be pure gold, because it will basically be the difference between us being able to do something, to fix something, to create something new, or not at all. Okay, so I hope this was useful. Maybe it was something that you could have thought about, but then again, not everything was crystal clear to me from the very beginning. I had to connect the dots, so to speak, between several things. So this is why I'm presenting it to you, because maybe it's something that you wouldn't have thought about on your own. So this video will prove to be useful. So thanks a lot for watching me. Thanks a lot for watching this video. If you found it useful, please hit the like button. If you would like to see more of this, more of my electronic projects and things that I'm learning in this domain, please also subscribe to my channel. And if you want to support me more, there is a Patreon account linked in the description. By helping me, by supporting me financially, you are supporting also yourself, because the faster that I will be able to buy components and devices, the faster I will be able to study things and come here on YouTube with new videos and teach you as well, so that you don't have to spend so much time and energy as I'm spending learning these things. Thanks a lot for watching, and I hope to see you soon in my next video. Bye bye.